Hello everyone. In today's class, let us start discussion about third law of motion, Newton's third law of motion. Okay. So, third law of motion definition, then after some examples, let us start discussion. So, what is the statement of third law of motion? Here, to every action, there is an equal and opposite reaction. So, for every action, there is an equal and opposite reaction. This is the basic statement of Newton's third law of motion. So, we can explain here by just look at the next statement. Forces always occur in pairs. Okay, means whatever the forces involved between two bodies, right, that always exert in or occurs in pairs, and those pairs we can actually call action reaction pair. So, both act at the same instant. Okay, na? So, means we can take some example here. Here two masses. Okay, na? So, let us write it is m1 and it is m2. So, when we consider two masses, the force between them is gravitational force. Okay, na? The influence force between them is gravitational force. Now, m1 attracts m2, like you can take here A and B, like that also we can take. So, A attracts B and at the same time B attracts A. So, whatever the force exerted by A on B, okay na, force exerted by A on B is action. Now, then at the same time B also exert force on A, then it will be reaction. So, now just we can understand clearly, when A exerting some force on B, that is actually towards A, FBA, force on B by A, and it is towards A direction. So, next the B exert force on A, that is FAB, okay. So, that is towards B side. So, now these magnitudes we can have equal, right, and they can act in opposite direction but through same line. That is actually major concept of what Newton's third law. So, from this we can write one force is action and remaining force is reaction, means second force is reaction. So, that is force exerted on B by A, if it is action, that is FBA is action, then reaction is what? Force exerted on A by B is a reaction. So, this is actually we can say, right. So, now F action equal to minus F reaction vectorially when we indicate, but magnitudes are same only. When we represent them as magnitude, then their magnitudes are same. Okay, na? But their vector form when we represent, their directions are different, so we use minus symbol. Okay, na? So, that is F action equal to F minus F reaction. That is finally we can write F action equal to minus F reaction. Okay, na? So, this is actually we can write and we can use in some cases to solve the numericals. Okay. So, what is once again, what is the statement of Newton's third law? For every action, there is an equal and opposite reaction. Okay. That is, to every action, there is an equal and opposite reaction. That is major statement and statement of Newton's third law. And forces always occur in pairs, that is action reaction pair, that is one exert force on the other is action and second one exert force on the first one is reaction, and both act at same instant simultaneously, means same instant, same time only these forces are going to be act. Okay, na? So, that is actually basic introduction. Let us move on to next slide. Here Newton's third law of motion, condition for reaction action reaction pairs. Okay, na? So, what are the action reaction pairs conditions? So, first occurs simultaneously. So, now we have seen in the last case mass A, okay, and here mass B. So, mass A exert force on B is action and mass B exert force on A reaction. They are happen simultaneously only. Okay, na? So, that is actually here occurs simultaneously. Act in opposite direction, their directions are opposite. Okay. Next, act along the same line, and this force must to be act along the same line. See, the line I use to join their centers, okay na, along this line only this gravitational force must be act, right? Along this line only force will act. So, here act along the same line and act on different bodies. Let us understand. First one exert action on the second one, means action on the second body. Then reaction exert on first one, here reaction on the first body. So, two different bodies are there. Action is on one body, reaction is on different body. So, that is actually explains act on different objects. Next, equal magnitude and same nature. Here equal magnitude, just now I told you this is FAB, magnitude must be equal to FBA. We have discussed in the last slide and their magnitudes are same. And for magnitude actually we learn in the gravitation lesson, okay na. Just if you note down, no problem. The magnitude of force can be given as GMA MB by R square. This is the magnitude of force with which they are influenced, means one exert force on the other one. FAB, FVBA magnitudes are equal to this one, but their directions are opposite na. So, directions are opposite. One is left side, one is right side. Okay. And your nature of the force between them is same. The nature means gravitational force. The nature of the force between the masses is gravitational force. Okay na. So, that is nature we can discuss. Equal magnitude and same nature this is. Right. So, these are the some conditions or characteristic properties for the action reaction pairs. First one occur simultaneously, second one act in opposite directions, third one act along the same line, fourth one act on different objects, and next to fifth one equal magnitude and same nature, right? Let us move on to next slide. Here limitations of Newton's third law. Newton's third law is not strictly applicable for the interaction between two bodies separated by larger distances in the order of astronomical distance. Okay. So, very large separation whenever two bodies are present means the separation between two bodies is very large, means astronomical unit, like not 1 kilometer, 2 kilometer, astronomical units. Okay na. In such a distance we can't apply the Newton's third law. Next, it does not apply strictly when the objects move with a velocity near to speed of light. Okay. So, speed of light actually 3 into 10 power 8 meter per second, and it is generally we can write 3 lakhs per kilometer per second, 3 lakhs kilometer per second. Okay. Means in 1 second 3 lakhs kilometer it will go for such an unimaginable speed when particle has. Okay. So, we can't apply Newton's third law of motion. Next, it does not apply where the gravitational fields are very strong. Okay na? And gravitational field is uniform, then we can apply. And then different and non-uniform cases, means non-uniform not exactly very strong. Okay na? Very strong means then action reactions are not maybe equal. So, that's what we can't apply the Newton's third law. Next, illustrations of Newton's third law here. So, you can understand a book kept on a table. This is one first illustration and first example we can study. And first book exerts some force on the table downward direction. Okay, this downward direction, it is called action. Now, at the same time, table exert force on the book, that is actually reaction force. Okay na? And these must to be act in the same line but opposite direction. Now, book exert action on the table. On the table, force applied by the book is action. Next, book exert force on the table is reaction. Table first body, book second body, means action reaction are different bodies. Okay na? So, this is also satisfied here. So, action exert on one body, reaction exert on different body. Next, second one, walking. Walking comes under or by, we can explain the walking by help of Newton's third law. Okay, how like it is? So, we apply force on the ground is called action force, and ground simultaneously apply force on our foot called reaction. Okay na? And here also force will be act along same line but opposite direction. So that's what we can just walk on the ground. Okay. So next third example, swimming. Swimming also we can give the example for Newton's third law. Here action is what? We push the water backside, that is action. And the reaction is what? The water push us forward direction, that is actually reaction. So action reactions are opposite direction and act along the same line, and in both the case you can see we apply force on the ground is one object, then ground exert force on us means we are separate body from ground. So action exert on ground first body, reaction exert on us second body. So two different bodies. Here person exert force on the water to push it, okay, push the water back, so that is action. Then water exert force on us, reaction. So body, water, two different bodies. Next, firing a gun. When just a bullet is fired from the gun, bullet leave with some force, that is actually called action force. When bullet leave from the barrel, it will move with some force called action force. Due to that, gun will move backward, that is actually called reaction force. So this concept we can have questions actually, and these questions we can solve from the concept of conservation of momentum. Okay na? So like we can apply the conservation of momentum here. So when bullet leave the barrel, momentum it will move with some momentum. So gun will move back to conserve the momentum. Actual principle what is happening here. So based on this one we have questions also. So just we can having only one small example in the Newton's third law, but question purpose we will explain in the next slides. Okay. Now flight of jet planes and rockets. Here rockets are filled with fuel and that are after burning, the burnt gases will come out with a greater pressure. Okay na? So that whenever that gases, burnt gases coming out with a greater pressure is called action. So due to that rocket will move up, that is actually due to reaction force. Okay na? Here also we can apply action reaction forces, right? So these are the some illustrations to explain the Newton's third law of motion, right? Thank you.